So this question is a diagram question. Anytime I see some visual input provided, I'm going to categorize the question as diagram. This is more specifically a graph question. So let's look at the graph. So we have a title here, U.S. production of plastic. The x-axis is number of years since 1985, and the y-axis is amount of plastic in billions of pounds. So the information provided here tells us that between 1985 and 2003, data were collected every 3 years on the amount of plastic produced annually in the United States in billions of pounds. The graph below shows the data and a line of best fit. The equation of the line of best fit is y equals 3.39x plus 46.89, where x is the number of years since 1985, which we knew because that's the x-axis here, and y is the amount of plastic produced annually in billions of pounds, which we also knew because that's the y-axis there. So question 21 is asking us, which of the following is the best interpretation of the number 3.39 in the context of the problem? Well, 3.39 in the context of the problem shows up right here. And again, because I always write down the equations as they're provided in the question, this equation, because it's the equation for a line, I'm going to look at in comparison to another or generic equation for a line, the slope-intercept form of an equation for a line, where the 46.89 would be the b, or the y-intercept, and the 3.39 would be the m portion here, or the slope. Right? And what does slope mean? Slope is actually a rate, right? It's a rate of change. And what are we focusing on the change of? We're focusing on how y changes, like per unit x. That's basically what slope is. How y changes, so let's say how y changes per, and this dividing line means per, right? So per unit x. So which one of these answer choices kind of matches this idea of what a slope is? So choice A says the amount of plastic in billions of pounds produced in the United States during the year 1985. Well, that's not how y changes. That's actually an actual y value, right? It's actually this point right here, right? That is the year 1985, and that would give us the amount of plastic. So that's not a change in y. So A is out. Choice B says the number of years it took the United States to produce 1 billion pounds of plastic. Again, that is more of a change in years, so that'd be a change in x. But we want a change in y. We want how y changes. So y again is the amount of plastic. So in this answer, our plastic is stagnant, but our years we're looking at how many years there would be. So it's just a reverse of what we really want. So choice B is gone. Choice C says the average annual plastic production in billions of pounds in the United States from 1985 to 2003. So that's pretty good, but the average annual plastic production, again, that's a single value, right? If I average all those numbers together, I'm going to get one single average, one number that represents the average. So it's not telling me how y changes, so C is gone. Choice D, the average annual increase in billions of pounds of plastic produced per year in the United States from 1985 to 2003. So that's a much better answer, because then that gets me like, how is this changing? So this annual increase part is not just saying what's the average of the production, it's what's the average increase of that production. And another thing we think about for slope is this idea of rise over run. So in our graph, right, if I'm rising, running, rise, went too high, rise, run, this process, this stepwise process, really is giving me like, well, how much am I going up, right, before I get to that next point? How much am I rising? How much am I increasing? So this idea of the average annual increase in billions of pounds of plastic, which is the y value, right? So that's how does y change per year in the United States from 1985. So the per year is our unit of x, right? Because x is in years. So per year is our unit x. So D is the best answer for those reasons.